Oh, Mijo. Hey, guys. We are doing the kind of final part of our tutorial, how to uh, demo, etc. on OpenStack, OpenDaylight, with the OVSDB project. We are going to boot up lots of nodes on a single laptop and see if anything breaks because of memory. We had some memory problems last night. I think we indexed around 6 a.m. That was on my machine. So we're going to try Madhu's out here and see. Now that we've gotten 2 hours sleep. As you can see, Madhu has the Open Daylight sweatshirt on.
Yeah, dude. Yeah.
That's fancy, man. That's fancy stuff. I mean, does everybody in the valley get fancy stuff like that?
Dude, don't tell me you didn't get one, right? You were wearing it for your gym practice, isn't it?
Maybe, but I did wear I did put on the SDNU T-shirt just because I mean when I'm hanging out with fancy guys I gotta be fancy. Thanks to Roy and Matt actually of SDN Central for this
Oh,
fancy T-shirt.
good for you, man. You know, right? Out in California, it's extremely cold, so it's like 50s. So I had to buy this sweatshirt. You know what I mean?
Yeah, yeah. I mean, you can you can get frostbite in 4 days with no clothes at
Yeah,
that
well, of
temperature.
course. Yeah, man. Uh,
All right, sir. Well, whenever you are ready, and
yeah, I'm ready. We can get started, man. So
all right, cool.
let me start my screen share.
Yeah, and we're gonna do a post with this also, so that you can follow along at home. Everything we're doing here is already in a post on my blog. I put it on the blog just because, not to be a total egomaniac or anything, but mainly just because our wiki is kind of in admitted kind of poor shape right now, and our project specifically. I'm not saying anything about the rest of the wiki. So,
Yes, sir. So do
but we're gonna get that cleaned up.
you see my screen, buddy?
I do, sir.
Is it okay? Should I increase the font? Or...
No, it's okay for me. Let me blow it up a little bit more. Yeah, it looks. I mean, it's small for me, but it's what I normally use, so I think it's got to be good enough.
All right, sir. All right. So in this demo setup, this is a continuation of the previous video that we recorded for the basic bring up of the VMs, how to import the VMs into VirtualBox and VM Fusion. And I myself is a VirtualBox guy, so my demo today is going to be based on VirtualBox. And the VM I'm using is Fedora 19 based. And in Brent's blog, we have mentioned both the 19 and 20. You can download either one of the images, but I'm using 19. I find it a bit more stable, and now the MySQL behaves reasonably well here. Um, so
Careful. We both work for Red Hat now.
yeah,
We have to
exactly.
be
So,
very careful when we say that. No, I'm kidding.
and the problem that happens is definitely not in Fedora 20. It's definitely on MySQL and MariaDB, right? I
Right.
think that covers our
Yeah, yeah. I
our
mean, it's totally those
problems here.
SQL guys. I
Anyways,
don't know what Oracle's doing. It's crazy.
and I'm using Oracle VirtualBox here. That's fine. So, in fact, the only reason we use VirtualBox is that it's free and we saw in Summit, 90% of the guys were using this one, so it's pretty useful for folks to use it. Uh, as you can see here, I have 5 VMs that is all running here. It's exactly as mentioned in the previous video. And for the controller node, I've given 4 GB memory, and for all other computes, I just gave 2 GB, right? So it serves well because my system is a 16 gig system. So with this one, now I was able to manage less than 16 gigs. So I'm good with this one. Um, I recommend using the similar kind of configuration for your demos if you guys want to try it out hands-on. So for interest of time, I already ran this. I already brought up those VMs. So the VMs are all right behind this thing right here. Should I increase the font here, buddy, or this is okay?
No, I mean it looks the same to me here, but my only concern is, yeah, let's put it up a little bit, man, just in case somebody's got bad downloads or something, and
Yes, sir.
it steps down the resolution.
Whatever you say, sir. Yeah, I'm almost there. Just that I have to. Okay, there you go. Yeah, I can switch this way because this is the trouble with Mac, where if you don't. All right, there you go. And I go to Fedora 4. And Fedora 5.
I see you've been running really on stack.
Yeah, I mean, I got everything ready to go, buddy. So let me clear so that let me not show the surprise or suspense before, right?
So wait, this isn't the first time you ever tried this.
Nah.
You kind of blew the cover, man.
Do you think I'm crazy to do that?
We should probably like show some proof that this is live and we didn't do this in Flash.
Exactly right. I'm trying to get there and so there you go. All right. So what we have here is the top two terminals are all the controller terminals, the terminal with OpenDaylight controller and OpenStack controller, and the bottom four are all compute nodes: Fedora 2, Fedora 3, Fedora 4, and Fedora 5. Right. These are all compute nodes ready to go, really. The configurations are very similar to what we represented in the previous video, but just to make sure we're on the same page, we do a cat on etc hosts. As you can see here, the IP addresses are all assigned appropriately. Here, the ifconfig P7 P1 is the port that we're going to use for the demo. The controller node is 56105. 106, 107, 108, 109 are the compute nodes, and they're all configured appropriately in the etc hosts. And let's do a vim on local.conf. All the IP addresses are configured 105, and so on and so forth. The host IP, service node, the host IP, the service host, everything is configured up with the IP addresses that we got here. Similarly, if you want to show it here, let's do the same thing. This is one of the compute nodes. Do I host? For simplicity, I just copied the configurations here. Almost the same. The only difference would be the 127.0.0.1 with Fedora 2 is the local VM, and the local.conf is the corresponding to the local.conf.compute copied over and modified the IP addresses essentially here. You can see that the host IP is 106, but service host is 105, which is the controller node. And OpenDaylight controller is running on the same controller node, so 105. So pretty much that is the configuration that you expect on the DevShack setup. And on the OpenDaylight side, the configuration is essentially on the config.ini. Here, look for OVSDB. Yes, and we are going to run OpenFlow 1.3 in our demo, so it is configured as 1.3. That's a quick rundown on the configurations. Now, let's start the OpenDaylight controller. So the idea is to start the OpenDaylight controller as the very first, and wait for a few minutes before we kickstarting the OpenStack nodes. Essentially, it's because we have a few timing issues where if we start the compute node, the OpenStack controller compute nodes a bit sooner, then we fail to learn them. So those things are the bugs that we'll address it as part of the subsequent releases.
Yeah, that's something that we'll talk about that on another hangout.
Yes, sir. I mean, I'm not really ashamed of bugs per se, because if we know it, we can handle it.
Oh yeah, and that's just like the ordering. At some point I think we have to block until we're stable or something. Do some checks on module dependencies maybe.
Right. So just to showcase here, this Fedora 2, 3, 4, and 5 all are ready to go right here. And on this side, if you're interested in debugging on the whether it's up or not, you can look for this this log right here. The log says OVSDB Neutron registered. That means OVSDB is up and running and is ready to go. So essentially, we can get started right now because even the meter config is running. So these are the logs that you have to look for before starting the OpenStack nodes, OVSDB and the meter config right here. With that done, let's stack now. So I'm stacking the controller node. It's going to take a few seconds. I can also do it rest in parallel. So what I'm going to do now is I'm going to keep the Fedora 5 not started, and I'm going to stack the other 3 nodes. I'm in Fedora 4, I started that. I'm going to Fedora 3, I'm starting that, and I'm going to Fedora 2, and I'm stacking that. So essentially what I'm doing now is we have the compute node, 3 compute nodes coming along, and the controller node booting up. Essentially we'll have just this configuration. Even the controller node is also a compute node in the DevStack setup. So with this one, we'll have 4 compute nodes. We can start spawning VMs on these nodes. What I'm going to do is once these are all working fine, I'm going to bring up the Fedora 5 at a later point of time, right? So that now we can really see what will happen if a new node comes along at a later point of time as well, right? So that's a very interesting piece as well. So now, as you can see, we have the stack is completed here on the Fedora 4. You can use regular commands like sudo ovs vsctl show. You see the br int is created by this stack. It's fine. Similarly, I'm going to check here. It is up, and I'm going to check in Fedora 2. It is up. The interesting point to note here is the manager is set up automatically to point to the OpenDaylight controller. So the manager here means is OVSDB connection. That's the manager. It's for a given hypervisor. If you look at the br int, is a bridge created on a given OVS instance. There we have the controller configured, and it's also configured to the same 105. But the port, of course, is different. 6633 is pointing to the OpenFlow connection. 6640 pointing to the OVSDB connection. So when you see this configuration right here, that means we are good to go. And of course, the connected true should also be true here. So we can check the similar kind of thing happening on the other compute nodes as well. This essentially means that we are in the right path, essentially. And the controller node is coming up. It takes a bit of time because it has a lot more services than the compute nodes. So it's coming along, and when you see the starting Neutron, you'll start seeing some messages on the OpenDaylight controller here, as you can see right here, right? So it's happening because now the Neutron that is coming up on the controller side, the OpenStack controller is sending northbound APIs to create networks, subnets, and the DHCP port, L3 agent port, so on and so forth. So it's happening. So everything is working as expected. And for now, just ignore the messages here because it's for the gateway. So I'm not too concerned about this one now. And it's going to take a little bit more time. In the meantime, Brent, you want to talk about anything else, buddy, here?
No, just you covered the offline piece in the local.conf, didn't you? Sorry, I'm building on this one too.
Oh, no, sir. Good point. So let's open a local.conf in one of the nodes. In the local.conf, make sure that the offline is true and the reclone is commented out. It's because if you want to run a tightly controlled demo within your own network and not getting the updates from the pulling the updates from the internet automatically, to do offline equal to true and reclone is commented out. That means we are running completely offline mode with no need to have an external connectivity at all, essentially. So
this is not guaranteed to work if you uncomment that, basically.
Yeah, it's because things are being developed on the branches, and when you do reclone equal to we have a reclone there, it's going to pull the code, and the code might be different on the DevStack side. So our recommendation, keep it as offline true and comment out the reclone. That should be good enough for you. And okay, it's almost there. If you look at the controller node, it's almost done. And it's, yeah, there you go, right? It took 305 seconds, but it's all goodness. Now let's look at the show. There you go. The moment the controller node came up, you see that VXLAN tunnel has been established from all the compute nodes as well. It has one tunnel. As you can notice here, we have 3. Let me also open the 4. Right. So all of these, from the controller node, we see one VXLAN tunnel has been established to all these 3 compute nodes, which is 6, 7, and 8, Fedora 2, and 3, and 4. And from the compute nodes, you see only one tunnel towards the controller node. This is because it is the controller node is where the DHCP agent is running and the L3 agent is running, right? So in order to get the services, the VXLAN tunnel is established automatically when the controller came up. It's all automatically done, so there's no manual work needed by the customer. What you'll start seeing is when you start launching the VMs on different compute nodes, you will see the tunnel will start being established between different nodes. For example, if I launch a VM instance on Fedora 2, you will start seeing a tunnel being created from Fedora 3 and Fedora 4 towards the Fedora 2, essentially. So it's a preview of what to expect, actually, right?
Mm-hmm.
So yeah, I mean, so now we have the tunnels established between these compute nodes, all automatic because of the DHCP agent here. Now, Brent and I, we both are CLI junkies, so we use a lot of CLIs. But if you are interested, we can also spin up the Horizon UI. It takes a bit of time because of the load in my system. So let it happen. In the meantime, let's go back to the CLI and start doing things. And thanks to Brent, he gave me a nice set of copy-paste stuff here, where I can create both GRE and VXLAN networks here. So what I'm going to do here is I'm going to create 3 GRE networks using CLI, of course. Before that, I need to do OpenRC admin. Okay. Now, one more important thing is I have a script called add image. Please run the script on the Fedora 19 VM. It's because when I built this Fedora 19 VM, I built it as a not as a 64-bit VM, but a 32-bit VM. But by default, the CDOS images that comes along on the dev stack is a 64-bit VMs only. So I manually added this script, add image. What it does is actually it adds a 386 image to a glance, and we can start using that image for our demos. It's because of the VM is a 32-bit VM. That's the idea. But this problem is not there with Fedora 20 because when we created it, we created a 64-bit VM. That's the only difference between the 2 different VMs that we have. Yeah. So now I added the image. Now let me paste this network create commands. So now we are creating the 3 different networks, GRE1, GRE2, GRE3, and we are also adding the subnets, 10.100, 10.200, and so forth. All right, so we have that. So if we do a Neutron netlist, you should see public and private, which is by default when the dev stack is up, and we also have GRE1, 2, and 3 all up and running with different subnets here. So one beautiful thing about this one is we can also have VXLAN network and GRE network running at the same time. Not a big deal. So I'm going to copy paste a few more commands where we are creating now VXLAN networks. So we are creating 3 more networks, GRE and VXLAN, and there you go. It's done. If I do a Neutron netlist, we'll see that we have VXLANs, GREs, everything in place, And the favorite topic of Brent is that, as you can see, GRE2 and VXLAN2, you see that we are overlapping IP addresses right here, and also the VXLAN GRE1, VXLAN1, right? So we can still have overlapping IP addresses thanks to netedness, right, Brent?
Yes, sir.
Yeah, it's pretty cool to see that.
I agree. I'm pretty excited about all this.
Of course, sir.
Hey, there was one thing I noticed. I was just kind of following along on mine because I've been using the 20 image. I had to do a service Open vSwitch start for whatever reason. I mean, I've run that a few times. It's in the post to just go ahead and do it, even though it might be redundant. But
All right. I mean, that's not needed in the setup. Everything is working by default.
What's that?
Yeah, for 20 you need to do that, right?
No, this was on the year 19 image.
Huh. I never had to do that before.
Yeah, I mean, I don't know.
All right, sir. All right, so now we have the VMs, I mean the network created. Now we can start booting the VMs. So what I'm going to do is we are going to create a GRE, we're going to create a instance, VM instance on Fedora 2. Now we are, if you look at the availability zone here using this command, we can actually specify which node to boot the VM, the instance on. And we're going to use the GRE1 as the network that's being created now. So I'm going to paste this command here. Once we have that command, it takes a bit of time for the VM to be loaded on this one. We can do a NOVA list to see whether it's active. It's building, so it's coming along on the GRE1 network. When it takes time, I'm nervous because this is when the error pops up on
the memory starts to explode. Yeah, keep in mind this is all on a single host. It's pretty amazing.
Yeah, and I think we are going to get an error here, if I'm not wrong. Because by now the VM should have been spawned.
Yeah, but you got so many going.
Yeah, but let's see. I see the GR internal created though. It's good news.
This is where we start getting depressed.
That's all right. And it was working fine before because I was not even having multiple networks. There you go. Boom. All right. So the VM is...
I started hearing your microphone clip out. I'm like, oh, there's the memory bomb.
It's all right. So the VM is up now, which is the GRE as active. And you know what, guys? Ignore this. There's ridiculously a lot of messages here because the OpenDaylight has a lot of logs enabled by default. I forgot to turn it off, so let's ignore this for a minute. And as you can see here, you start seeing these tunnels being created from the neighboring switches now. Originally, we saw only the VXLAN tunnel being created before. Now we see that VXLAN, the GRE tunnel is being created from the 105 to 106, 107 to 106, and so on and so forth, right? So, you see that GRE tunnel is being created, and
so that's going to be full mesh, just so everybody's kind of clear on that.
That's right. Now we have a full mesh. It's not a full mesh end-to-end but what we have done is we have created a VM here. So how do we do it now? So NOVA list is already there. It's spawned on this VM, on this host, Fedora 2. And if you do a NOVA list is 10.200.1.2 right here, which is a GRE network. And you can see that we have tunnel established from all other VMs towards 106 here. So 108 to 106, 105 to 106, 105 to 106 again, we have GRE and VXLAN here, and 107 to 106. And when I go to the Fedora 4, you'll see that there's no 108 to 107 here. It's because there's no VM that is spawned on 107 or 108, so there's no need for them to talk to each other. So we kind of optimize the tunnel creation only based on the VM location, really. So that's a good enhancement, really. So with that done, let's also create one more VM. In this case, let's take a VXLAN 2, right? And let's launch it on Fedora 3. So now I'm creating a VM on 107, right? So once you see 107, you can start seeing more tunnels created from other VMs, which are interested into talking to this particular host, which is Fedora 3 in this case. And do a node list to make sure the VM is coming along. As you can see here, GRE1, this network is up, this VM is up, while VXLAN 2 is coming along. In the meantime, as it comes up, let's explore a few commands. The netns command, where you can see that there are DHCPs being spawned because of different, we have different networks being created. So every network will have its own corresponding DHCP node. And you can see that we have these various netns being, QDCPs being spawned right there. And we'll use this for now for our demonstration. Still coming up. In the meantime, let's go and see what's going on here.
Maybe show. Do you want to show maybe flow mods while that's coming up, buddy?
Oh yeah, that's a good point, buddy. Yeah, so both are active, but it's a good point. Let's look at the flow mods now. If you do a sudo OVS OFCTL, I'm blanking, guys. Okay, yeah. Dump flows, brint, o, OpenFlow 1.3. All right. So since you're using OpenFlow 1.3, it's beautifully installing all the flows in multiple tables. We have table 0, table 10, and table 20. So I'm going to maximize this so that we can enjoy this thing. And let's go to table by table. So it's good to see. Right now we are in table 0.
Take your, don't feel the need to rush this one. This is important stuff. It's pretty cool, man. So.
All right, sir. I'll keep it slow, right? So here, as you can see, we are in table 0, and the beautiful thing about here is you can start seeing that as and when we create tunnels, you can see that we are terminating those tunnel endpoints right here. And for every different tunnel, 3, 4, 7, 8, all these are the OpenFlow port number for the tunnel interfaces, the GRE VXLAN tunnels, and we are matching them with the GRE and the VXLAN key, 0x3E8, 3E9, and so on and so forth. And we know that table 0 is the default table used by OpenFlow 1.3 when the traffic hits the switch either from the tunnel or locally from the VM generated ones. So what we are doing here is whenever we know traffic is coming from the tunnel, and this table 0 is called the classification table, where we classify them based on which tenant they belong to based on the tunnel ID, and then we send it to table 20. So table 20 is going to take care of all traffic that is ingressing the switch from the tunnel, from the tenant. All tenant traffic comes from the tunnel. And you can also see these ones here, right? These are traffic originating from the VMs and doesn't match the source MAC. So these are the legitimate traffic coming in from the source, from the VMs, the instances that we spawn, and the DHCP things, right? So whatever is coming from them, we set them appropriately to we match on the source MAC, but whichever doesn't match, we drop them. So all bump traffic, all unknown unicast traffic are all dropped. We don't flood unknown unicast traffic, but we flood only the ARP and DHCP. And those things are all in table 10. All right, if you look at table 10 is for egress traffic, where traffic is coming in from the VMs. As you can see here, it is coming in from a VM and is going to table 10. There's a chop here. You can see table 10, 1 and 0s right here, right? So traffic coming in from the VM is going to table 10. And if it is a flood traffic, right? The flood, it's a broadcast essentially. If it is a broadcast or a multicast, we map using 0101. OpenFlow 1.3 supports demask, destination, even MAC address masking. It's pretty cool. So we are using that feature to mask just that top 1 bit to figure out whether it's broadcast or multicast. And in this case, if it is an R packet, we are just flooding it to all the tunnel interfaces, 3, 4, and 5, right? So this is just the first instantiation of our implementation where we decided to flood the ARP and the HCP. But in the Helium or the subsequent releases that we are coming along now, we are planning to have ARP responder or punting the traffic to the controller to handle that. So there are a lot of cool things coming along. It's really interesting. If you guys are interested, join us. We can have fun with that. And in addition, you can see that the DL destination, based on the destination, we are sending out to the appropriate ports right here, right? So this is table 10 for you. And table 20 is for that, as I said, the traffic is coming in from the tunnel, is going to go towards the VM here. So we do exactly the same here. We do a lookup based on the tunnel ID, which is the tenant classifier, and the destination tunnel, the destination MAC. So using these two, we know exactly which port to send the packet to. So this packet will be sent to the appropriate VMs. And one more thing is we also have a flood entry here. The flood entry here is for flood traffic, the broadcast traffic coming in from the tunnel and going inside a given tenant. So for every tenant, whatever VMs that we have, the traffic will be flooded to those VMs. So that is pretty much that is it. So the explanation I gave you here is these are all from on the controller node, and you can expect the exact same thing on all the computes as well. So I do a compute, you'll see a very similar set of flows, very similar set of information. There's absolutely no difference. And the reason we did it is it makes life so simple for all of us to debug things. And pretty much that's it. That's the overall explanation of the flows that we have. And if you do a sudo OVSDB show, you can see all the tunnels being created across the nodes. All the tunnels are created. One is GRE, one is VXLAN. On each one of them are the important point is the key equal to VLAN flow here. So when you see key equal to flow as the tunnels options here, this means that I want to have only one tunnel between any two VMs. So as you can see here, right, I have any two nodes, not VMs, any two nodes. So we have 106 to 107. We have one tunnel for VXLAN and one tunnel for GRE. It can be how much ever tenants you can. You can have tens of hundreds of tenants. All of them will use reuse the same tunnel, VXLAN or GRE, and the key for them in GRE case the tunnel ID, and the VXLAN case the VNI is going to come from the OpenFlow message. And the OpenFlow thing, as you can see here, I'm going to showcase this table 10, and let's maximize it here. You can see that the set field indicates that it's the field 0x50514 is populated on the tunnel ID, and that's exactly what is going to be used on the key equal to flow. So this key 504 is used as the key when the traffic goes out of the tunnel. That's exactly why we use OpenFlow 1.3 here, because it's much more scalable. We have just one tunnel per type, GRE or VXLAN, between any two compute nodes, and the same thing is shared across all the tenants. So it's a good scalable story that we have. Brent, do you want to add anything, buddy, there?
No, I was just the only other thing I was thinking was maybe talk on this. So there's an Assyria extension for the same. So while we have key equals flow, we're hard coding in. Well, we're not hard coding, but we're programmatically coding in the OVSDB IPv4 tunnel source and tunnel destination. So right now that's being done with an Assyria extension. You know, we're pretty agnostic to it.
So no, in our case, to be clear, right? In our case, we are not using any necessary extensions, right? We are using purely everything is OpenFlow. I mean, everything is OpenFlow 1.3 standard based, and the necessary extension is used by other solutions like the NVP or or even the OpenStack's native OpenVSwitch plugin uses the NXM headers, which we don't use it here, right?
Yeah, and sorry, so when I meant I meant I meant OpenStack. Sorry about that.
Right. So in our solution, meaning using the OpenDaylight, it's purely standards based. It's both OpenFlow 1.3 and OVSDB. It's with no extensions, no proprietary stuff at all. That's a pretty cool thing here.
Oh, that's awesome.
Yeah. So yeah, so that is the high level, not I don't know, deep hands-on stuff on showcasing what exactly each one is. And for those who are much more inquisitive about this one, I'll also showcase one more command, the sudo OSDB client dump. So this command is a God-given command for debugging OSDB problems. So this one showcases everything that you want, all the tables in OSDB. So it's very, very useful for debugging. So guys who wants to use it, please take a look at it. It has all the cool stuff that you would want to know. All right. So having said that, so Brent, do you think we want to do a ping and showcase that we can do a ping across VMs?
Sure, and I've got some up too here. If either way, I'm actually doing that as we speak. Was there anything else that we needed to? There was one other thing I wanted to touch on that I thought we should. Did you mention that some of this functionality isn't available in Horizon also?
Yeah. Oh, yeah. Good point. So, okay, I spawned the Horizon UI as we are talking before. I forgot about it. So I'm logging into it. It's kind of, I mean, Horizon UI is a bit more slower in my setup because of the crazy VMs that we've been running, but it's okay. We can deal with it. As you can see here, you can look at whatever we created there. Everything is in the Horizon UI right here. So we see VXLAN, all the tunnels that we created right here, all the networks. It's all right here, and all the instances that we spawned should also be here. It takes time, guys. Okay, let it catch up. As it catches up, so let's try to do a ping on this thing where this is a Nova list with these are the two instances that we have. So you can do a verse. What's the command? Verse show, right? Or
verse list.
Verse list. Okay, that's the thing, right? So verse list is a command to showcase all the VMs available. So in this case, the VM is not spawned on the control, but we spawned on the Fedora 2. So you can see there's a VM running on Fedora 2, and there's another VM running on Fedora 3. Fedora 4 here. Sorry. Fedora. Where is my body? Fedora 3. There you go. Yeah, there you go. So I'm back in the controller, and let's try to see the ping works. So as we know that we have two VMs spawned on these two compute nodes, and we have to make a guess here. So since we have multiple networks here, we have multiple DHCP, QDHCP network entries. So what we can do is let's try to pick one. So I'm going to make a guess here, because since GRE1 was the second network that we created, so what we can do is I can do a sudo ipnetms exec DHCP, and now we can execute any commands you want to as part of that readiness. So I can do a 10.200.1.2 is because this is the IP address of the VM that we spawned, which is here on the GRE1 network. All right, so let's do a ping. Voila, the ping succeeded. That means that the traffic is flowing end-to-end from the controller to the compute node, back from the controller to compute node, from the compute to controller node back, all using through the VXLAN, sorry, the GRE tunnel in this case. So ping succeeded. So the way to confirm the data path, the best way I do it is using the commands, OF commands, right? So I trace the command from table 0, table 10, and table 20, and then match the appropriate MAC addresses, and do the corresponding one on the computer as well. And using that, you can see the packet counts going up, and you know exactly what happens that way. And let's go back and do it again just to make sure it works fine. Yep. So that is it, guys. This is end to end. And let's see what Brent has to show us now.
Got it.
Yes, sir.
Tell me you can see, please, sir.
I can see myself, yeah.
Okay, perfect. So we've got all the instances up. I'm going to throw one or two more out there real quick, just because I'm all happy that I'm not having memory problems right now, so I got to do one more.
Is it 19 or 20, buddy?
19. Not a word. Not a word out of you.
I'm a 19 guy, man.
Yeah, we've been going back and forth on this, guys. So, but here's one thing to point out. So we're booting a few different networks, but these are basically, so if you're a traditional networking guy, you're going to think of these as VRFs. So these are segmented networks. So here's what, 4 VMs on GRE1. So that's a GRE encapsulated overlay. Here's just one on VXLAN 1. Here's none on VXLAN 3. So we can always go back and, so those are, what those mean are those are networks that are defined that don't have anything on it. So I'm going to take this, I'm going to boot one on VXLAN 3 here really quick. That is on, I'm going to put it on host 3. So bear with me 2 seconds, I'll boot this host. And notice over here, we see the API calls going into the controller. And one more second here, and we should see it appearing. And now we've got it here.
Oh, dude, this is cool, man.
You know, they've done an amazing job. I mean, look, can you even see the little showing that it was booting before it was active, and then now it just went active?
Actually, I never saw this. Where do you see it? Network topology. All right. Okay, thank you.
Yeah, I'm a little bit behind on. We tend to lag when we're going back and forth between Fancyville and Kentucky.
Yeah, you are fancy, man.
You're fancy, then. No, Fancyville is. So there's one other thing on the Deluxe project is focusing on. So a lot of the analytics and data that you have here from compute and storage, we're working on getting into the dashboard, into Horizon also. So you'll be able to kind of pull some more data, and you know we're really trying to complement OpenStack because it's such an important project. So let's see, is there anything else, buddy? I love what they've done with this. This is actually really cool. I think we can do some more cool stuff and tie in some of the underlying network.
To me, management piece is one of the most important things if for such a complicated system like what you're seeing here, right? With OpenStack, OpenDaylight, and VXLAN and whatnot. So yeah, I mean this is. Hi guys, this is a minor addition to the previous video that we recorded. In previous video that we showcased the ping was working from the using the IPNetNS QHTCP. But later we realized that it would be cool to show how to do a VNC into the actual instances and show the IP address being assigned and so on and so forth, right? So because instead of ping, if you want to do SSH into another host, or so on and so forth, right? It'll be useful to have that working. So in order to showcase that, what I typically do, I'm going to showcase what I typically do, and many folks have different ways to do it. You can use the Horizon UI and do the user console on that, but I have trouble with that using my browsers. So the way I typically do is using the port forwarding. So the way to do it is I go to the host where the VM is running, and I do psef vnc, and as you can see here, there's one QEMU instance running, which is the instance for the is the process that is launched for the instance that we ran on this particular computer on this compute node. And you can see the VNC is bound to port 0, and by default the VNC port is 5900. That we have to keep a note of that, and you can see the Ceros image running here. So to begin with, we can break into the SSH shell by using ~c. So I'm using a Mac, so I'm doing a shift ~c. So now I'm into the SSH. So just to make sure it is tilde, that is the this is tilde, and this is the capital C. I'm just typing it just to showcase to you guys. And port forwarding is -l, so you can do -l and assign a port number on your local machine. So I'm going to say 5910 colon localhost. This is localhost is the local the compute node, and do 5900. So now I'm actually forwarding the 5900 of the host, in this case Fedora 2, to 5910 of my local Mac. Right? It says forwarding port. That means it is actually being forwarded. Similarly, I'm going to do if you want to look at this one now, I'm going to open my chicken of the VNC. I have a chicken of the VNC right here. I'm going to create a new connection, and now this is running in my local Mac. So I'm going to localhost and port 10 because we went to 5910. We forwarded the VNC to 5910. So I'm going to go to localhost 10 to a connect. All right, so now you are into the QEMU instance. So the reason we're directly into that is because last time I tried to make it work, but typically it will be like this. When you do, it will be like waiting on a Ceros image. So you can do a Ceros followed by Cubs win. So it seems like a Chicago Cubs guy who wrote this, who gave this Ceros image to the community, and hence the password is Cubs win with a smiley there. All's good, man. All's good. So now we can do a if config. So now you can see that IP has been assigned as 10.200.1.2, and now you are actually logged into an actual machine. This object